Hello and welcome everyone. So I'll be explaining recent Div 2 round like 720, problem A and problem B both. Now, quite interesting. Problem A and B both were quite interesting. I really enjoyed it solving. So let's jump into and demonstrate the problem statement first. Now in the first problem here, we actually going to be given two integers A and B, and we have to define it or output three integers x, y, and z, and the condition is that they have to be different positive integers, and x plus y have to be equal to z, and z have to be divisible by a times b. Okay, so a number z, so what we have to output is x, y, and z, and the condition is that x plus y have to be equal to z. So I have to build a relation here between x, y, and z, which is the addition of those two values, x and y, should be equal to z. And now what is the condition for z? Z's condition is that it should be divisible by a times b. Okay, so a times b, if I refer to as a number, it should be divisible by that number. And for the rest of the two values, which is meaning by x and y, they have to be a value such that it is only divisible by a, not divisible by a times b or anything else. Okay, like not divisible by a times b and only divisible by a. So we have to build only exactly one integer which is going to be divisible by a times b, and the other two should be divisible by a only. Okay, I hope you get that. This is what we can refer to as nearly good number. Remember, nearly good is only if it's divisible by number a. Now the question is how we're going to be building the number z. Let's focus on z. Now they have said that z should be divisible by a times b. Now how I thought this problem was, okay, so I have to define some number which is divisible by a times b. Why don't we just print the number which is the number itself that's going to be divisible by that? Yes, that's exactly what I'm talking about. What if we print the number z, z as a times b? Because if we do that, we have a, okay, first of all, we have to also consider a condition where it's not gonna the answer might not exist. When the answer is not going to be existed, the answer is not going to exist when b is equal to 1. If b is equal to 1, there is no way you can make three integers x, y, and z, and they should be different, and they should get into, like, you could make the relationship, and you could output that. So that's the first case. There are basically three cases. The first case is if this number b is equal to 1. The second case is if this number b is equal to 2, and the general case is that apart from 1 and 2 value. Okay, so let's define the generalizing case, then we're going to be dealing with the rest of the corner cases. Now first of all, how we did that was z, the number z, we will define it, the number z is as a times b itself, because we know a times b, obviously if I refer it as z, it will definitely be divisible by a times b also. Now what about the rest of the values? If I refer z as a times b, what if I do something like that? What if I do and I refer x as a times 1 plus y as a times b minus 1. Did you get my point? A times 1 will be referred to as x, and y should be a times b minus 1. How is this helping us? Just imagine if I refer a times 1 and a times b minus 1, what is actually giving us is that I can actually divide this number by a, it is divisible by a. Both of these numbers are divisible by a, and both of these numbers are not divisible by a times b minus a times b, right? So that's how we're going to be building for the values when b is greater than 2. Okay, now why is this like the additional operation gives a times b? That's obvious. If you just simply do the arithmetic operations here, you will find that a plus, it's definitely a is like what, b time a is b times a, I could say. So what if I say b minus 1 times a? Just add 1 times a to, which does mean like the answer would definitely output as a times b. So that's basic arithmetic operation. So that's exactly as simply I just thought that. And what about, let's move on to the base cases. The base case, the corner cases. Why it's not possible if b is equal to 1, the integer that we're going to be given, b is equal to 1. Why it's not possible? It's obvious, because if you see, if b is equal to 1, there's no way I can make, or there's no way I can like group this number into 2 parts, because the number itself is 1 times. That's obvious. So that's why if b is equal to 1, the answer would definitely be no. Okay, let me check. Oh yeah, it's recording. Okay, so b is equal to 1. Now apart from that, I have another corner case, which is if b is equal to 2. Now why is that a corner case that we need to consider here? Okay, we need to consider here because they have already given us a test case related to that. Now let's check it out. I've got 13 and 2, right? What are those values? Let's see. I've got like 13 and 2. 13 and 2, this is my a and this is my b. I know that my b is 2, so I have to consider a extra corner case for that. So if b is equal to 2, I have to take care of extra case. Why do I have to take care of it? Why I cannot do in generalizing way? Let me show you why. If I do it in a generalizing formation, the thing it's gonna output is, let's say I have 13, right? So I would say that yes, one of my numbers is 13 times 2, and the rest of the numbers I know what I said, that was one would be 13 times 1, and the other value would be 13 times b minus 1. b minus 1 is actually giving me 2 minus 1. 2 minus 1 is actually 1. Now that's not what I wanted. Okay, so why is this not helping us? That's not what I wanted, so I have to like take care of it in order to so about time, why it's not helping us? Because we have to create 3 different integers, right? A, B, and C. Like x, y, and z should be different integers, 3 different integers. Now, this is not different. If b is equal to 2, I know that if I do in a generalizing way, then these 2 integers a and b won't be equal. As you can see, they are not equal. They are equal, sorry for that. They should be distinct, these 3 values, but if I do in a generalizing way, they become equal, which I don't want that. Now that's why we have to multiply something with this. Now you can multiply any number which is like favorable according to the solution, but the way I did was I multiplied 3. So if I multiplied 3 with 13 times 2, or the number that they're going to be given, so for the case where b equal to 2, our output would be a times, for z value, the output would be a times b times 3. Okay, remember this is the corner case. a times b times 3, only for b equal to 2, okay? So the z would be a times b times 3. Now, if z is a times b times 3, then I know that I could refer it as 3 times 2 is what? 3 times 2, I could say it's 6. 3 times 2 is 6. Now, this 6, how many times it comes? Like 13 comes 6 times. So if 13 comes 6 times, then for that, I will always refer something like that. 13 times 1 plus 13 times 5. That's it, nothing else. That's the extra case for we need to consider for for the case of 2, like b, when b becomes equal to 2. Let me take you to the code section, as easy as you like taking a and b. If b is equal to 1, answer is no. If b is not equal to 2, the generalizing case, which I have already talked about, a times b minus 1 and then a times b. And if b is equal to 2, then just output yes, and yes, and then a, which is a times 1, and then a times 5, always, because we are actually multiplying 3. 3 times 2 is 6. I know that one will be 5 and then another would be 1. So 1 plus 5 equal to 6. That's why we're dealing with like that. Now, about time, let's jump into the problem B. Now, this was quite interesting. Quite interesting problem. Now, let me derive it how we did this problem actually. Now, basically, before jumping into this problem, you need to know one thing for sure, which is that there is not much difference, okay? The generalizing knowledge that you need is that there is not much difference between two numbers of range like 1 to 2 into 10 to the power 9. Let's say any number which is being ranged like that, like let's say a number is ranged between 1 and 2 into 10 to the power 9, right? Now, if you just do linear operation and try to count the exact adjacent or the exact closest prime number, you don't have to do any kind of rocket science algorithm, because the difference between these two prime numbers, or difference between two adjacent prime numbers, like two closest prime numbers, difference between two closest prime numbers, it's really small for the case up to 2 into 10 to the power 9 or 10 to the power 9, like 200 or 300 numbers, not much. That was the key fact. Because in this problem, what we had to do was basically we're going to be given an array and we have to make this array good. Now, how we're going to be making this array good? The good definition by this array is meaning that each and every adjacent two values, GCD values, which is the greatest common divisor value, should be equal to 1, which means they should be equal to coprime. Okay? So I thought that, okay, if our given arrays, each and every adjacent value should be coprime like this, they should be coprime. Then I thought that why don't I just and also I can do some operations in order to make the array good if it's not good initially. And they have also stated that it's always possible to make the array good, and I have to use at most n operations. So to make the array good, in order to make the array good, I can use at most n operations, and they have also stated that it's always possible. It's obviously always possible, because if I know any prime number, I know that any number will, apart from that prime number itself, if their GCD would definitely be always 1. And also one tricky thing is that here, if you look at the constraints that the array is going to be given, inside this array that we're taking, the constraints values of each array is up to 10 to the power 9. But the real reason is that what was the operation? The operation that you could make in order to make the array good, which is you could select two different indices, and if you take the minimum out of them, first of all, the operation works is like you take two different indices, and you take another two different integers. That's for your choice. Now these two integers, they're gonna be from 1, their range or their constraints are gonna be from 1 till 2 into 10 to the power 9. That's interesting. That's where my mind tricked, that like I got the idea right away that yes, I can do something out of it. Because like, let's think about it. I'm tracking, or the two integers that I'm going to be taking is going to be of my choice, and they're up to 2 into 10 to the power 9. But the result that we're going to be inputting, or like taking the array that we're going to be taking, their value is going to be only up to 10 to the power 9. So I have a possible outcome of prime numbers that I can get, which can be closest to 2 into 10 to the power 9. So if I could somehow find that, that is gonna play a big role in order to make the array good. Also, the operation after that states that you take two different indices, you take two integers of your own choice, but you can change them, like ai to x and aj to y. But there's a condition. The condition is the minimum out of ai and aj should be equal to the minimum of your own choice. Now what does that statement actually mean? That statement actually refers that out of those two integers, one of them should be the minimum, and you have only choice, like your choice of independent choice. Your independent choice is actually only one integer, not two, by allowing this statement. Why is that? Because, like, simply imagine if the minimum, now also they have stated that this minimum out of ai and aj, this is before the operations. Okay, so before the operations I have to consider the minimum. If I take the minimum from ai and aj, I'm just bound to take one integer of my own choice, which is I'm bound to take out of these two, which is the minimum. Okay, I hope you get that, what I'm trying to understand or make you understand. Like, let's take you to an example too. Let's say I have to take the minimum. I want to change the value of index 2 and index 6. Now let's assume that the values are like 2 and 5. Now I can only choose one value independently, although they have stated that I can choose x and y independently. But by allowing this condition, I can only choose, like, freely only one value, and that value is definitely going to be a prime number, which is and the other value should be the minimum out of these two. Because if it's not going to be that, then I know that this condition is not going to fulfill this condition right there. So overall, I have to only pick one independent prime numbers, and that prime number is going to be closest. What I took was, I took the closest prime number, which of 2 into 10 to the power 9. Okay, I took the closest prime number of 2 into 10 to the power 9 because I know that will guarantee me the result. Now, how we're going to be building the result after checking out the prime number, or after taking the prime number, the total number of okay, after taking the prime number, let's say we want to take, after taking the prime number. Also, one thing to tell you, that the number of operations is going to be k by 2. N by 2. N is the number of elements of the array. Why it's n by 2, I'll explain you why is that. The way we're going to be building is, first, how I did was, I actually built the new array. Okay, and then according to the new array, I printed the result of which values that I took, and then which values that I'm outputting. So the new array is going to be built something like that, which is, I will only care about, or first of all, I will do only operations like that. First two, and then next two, and then next two, like that. If n is odd, it doesn't matter. order even, it doesn't matter. The answer is going to be n by 2 operations. Why is n by 2 operations? 1 2 3 4 5 6 7. Now look, this there here n is equal to 7. Now 7 by 2 is, I know that 3. 1 2 3, so 3 operations. Now what am I actually going to be doing inside these 3 operations? Inside these three operations, what I'm actually doing is each and every operation's second value, like when I take the 2 length of subarray like that, in the second value I'm always inserting my prime number. But also I have to recheck if this value in our, like when in our previous array, or the array that we took primarily, what is the value inside here? Is it the minimum out of these two? If it is, then do replace this value with the previous one. If it's not the minimum here on the previous array, then just place it as it is, because we know the minimum is definitely here. So I have to like, this is the new array and this is the previous array. Let's assume this, I've got a previous array, which is the array that we're basically going to be taking. The new array is going to be built upon or depending on the previous array. For each and every operations second, like 2 length subarrays second value, we're going to be inserting a prime number. But we also have to check, and we also have to check whether the place that I'm putting the prime number, whether in the previous array was there a number which is the minimum out of these 2 values that we are considering. If it was the minimum and it was placed right where we were inserting the minimum, like inserting the prime number, then we have to replace that value. Then we have to replace that minimum value and insert here just the previous of that prime number. If it's not the minimum one, then I know that the minimum is already there. So just print the value as it was. Okay, so that's all we have to care about for each and every, like, 2 length of subarray. But they're going to be considering like that, the first 2 and then the next 2 and then the next 2, like that. Okay, so that's all we're going to be building. That's how we're going to be building this array itself. And then after just then the answer is easy. We have to take and output how many operations that we took, and also we have to print 4 integers I and j of what are the indices that we took and what are the integers that we took. We know that out of these 2 integers we have to print the values that were previous and then the afterwards. I hope you get that. Also I'm going to be demonstrating the code part 2. So that's how we actually did this problem. Yeah, so I hope you get the part where we're checking the prime numbers, the closest prime number of 2 into 10 to the power 9, and the difference between 2 adjacent prime numbers or 2 closest prime numbers is so small. You can even do brute force. You don't have to go for any kind of rocket science algorithmic implementation. No, it does not. You don't have to do that. Okay, so the way it works, first I took the prime number before taking even the test case. Okay, this is the prime number that I'm taking from the back. Okay, so I'm trying to guess the greatest prime number up by for looping previously from 2 into 10 to the power 9, like that. Like solve by, it's just the basic operations, you know, like big of root over big of root n complexity, which is basically giving us if a number is prime or not. It's a simple algorithm, and this is the looping part where we're checking what is the closest prime number that we can get for 2 into 10 to the power 9. Okay, after taking that prime number, we are actually taking the value itself and taking the integer value, taking the minimum value and also the position. Okay, sorry, actually this part is not needed, I think. Yeah, this part was basically useless I don't need that part. Actually, I was trying to do something else before I reach out to this solution, but I don't actually need this part. Okay, anyway, the answer would be n by 2. Of course, we know that, k by 2 or n by 2. And after that, what we're doing is building our new array. How we are building it? Just think about it. We are checking, like look, I is starting from 2, and then I is incrementing by 2, which is basically trying to find out first 2 and then second 2 and then third 2, like that. And if each time we're checking the minimum of AI and AI minus 1. Remember, this AI is our previous array, and I'm checking the minimum. If the minimum is inside the index where I'm going to be inserting the prime number, then I'm actually inserting then I'm actually going to insert the minimum number in the previous index of our new array, and inside the inside the current index I'm going to be inserting the prime number itself. If it's not, then I know that our minimum value is already there, so just basically temp of I minus 1, which is the new of I minus 1, is equal to a of I minus 1, the previous of I minus 1, because I know this a of I minus 1 is actually referring to the minimum value. That's all. After that, just printing those like each and every sub arrays or each and every operations values, which is I minus 1 and I, the two indexes that we're considering, and the two values that we're going to be taking, which is basically the new one. That's all. I hope you understand about the full part, and yeah, I hope I made you understand that. Yeah, till next time, goodbye. Yeah.